in my today's session about electromagnetic field, and today we are going to discuss the different problem on conductors and dielectrics. Although I am Dr. Sayanti Chatterjee, the Associate Professor of Electrical and Electronics Engineering in IARE College. My today's topic is based on the tutorial question bank provided from the students. So, first our problem is about first problem of this topic is about the capacitor. Calculate the capacitance of a parallel plate capacitor with the following details. What are the details? The parallel plate area is 150 centimeters square. Check the units very carefully before starting any problem. Dielectric of the FR1, this is the relative permittivity, is given as 5. The length D1, the distance between two plates, are given 3 mm. Epsilon R2 is equal to 4, the relative permittivity of a second dielectric. So this is like, we can think there are two parallel plate capacitor, and what is their value? 150 centimeter square, and there is two dielectric between them, not a single dielectric, two dielectric between them. For the first one, the FR1, what is the value of the FR1 is given as 5, and FR2, I am writing with green, the FR2 is equal to 4. These two values are given. The distance D1 and D2, so this is the D2 distance, and what is the value of the D2 distance? 4 mm. And what is the distance between the D1? D1 is the value is given as 3 mm. So these value are given. We have to calculate the total, what will be the voltage gradient across the each dielectric. So this problem is little tricky, and there are several types of formulas are used here. I will discuss one by one. So as it is given, the A cross-sectional area is 150 centimeter square. We are changing it into the millimeter square, and we are getting 150 into 10 to the power minus 4 meter square. What is D1? D1 is equal to 3 millimeter as it is given, and epsilon R1 is 5, the relative permittivity. So epsilon 1 is equal to epsilon R1 into epsilon 0 is equal to 5 into 8.854 into 10 to the power minus 12. What is the second distance? 4 millimeter, means 4 into 10 to the power minus 3 meter. Here also 3 meters means 3 into 10 to the power minus 3 meter. Epsilon R2, the relative permittivity of the second one, and epsilon 2, the epsilon 2 will be epsilon R2 into epsilon 0 is equal to 4 into 8.854 into 10 to the power minus 12. And we can see, if we connect any voltage source across this parallel plate capacitor, current will flow in series. So we can think that the both capacitors are in the series connections, and if the both capacitors are in the series connection, we can tell that the equivalent capacitor is equal to C1 C2 by C1 into C2. 1 by C equivalent is equal to 1 by C1 plus 1 by C2. So we are using this formula. So our first step is using the capacitance of the first plate. So what is the capacitance of the first plate? The formula is epsilon A by D. Now we know the value of epsilon, we know the value of A, we know the value of D. If we put the value, we can get the value of capacitor C1. Similarly, if we put the value of C2, we can write same formula epsilon A, epsilon 2A by D2. Epsilon 2 value is also given, A value is given divided by D2. So we can get the value of C2. Now, according to the formula, the C1 and C2 are in the C1 and C2 are in the parallel combination. So if we put the value of C1 and C2, we can get the total value of the capacitance. So first step is we have to change all the units in meter. Then we have to calculate the value of C1 and C2. C1 is equal to epsilon A by D, C2 is equal to epsilon 2A by D2. Now, what is the overall capacitance or equivalent capacitance? Equivalent capacitance equals to C1 into C2 divided by C1 by C2. Now, we are coming to the second part of the problem. So, what is the second part? Now, already we got the C value. Now, if 220 volt, if the 220 volt applied across the plates, what will be the voltage gradient across each dielectric? As I told earlier, we are connecting a source between these parallel plate and the value of the voltage is 220 volt. Now, we have to calculate the voltage gradient from the each conductor. So, already we know according to the definition of the capacitor, C is equal to Q by V. So, already we know Q, we know the capacitance C, and we know the voltage. Voltage is 220 volt given in the problem. If we put the value, we will get the total charge of Q. Now, what is the second point? So, as for the both plates, the total charges remain same. For the both plates, the total charges remain same. Capacitance value we know. So, we can calculate the voltage across the each capacitor. So, we have calculated C is equal to Q by V. We are using the same formula for the first capacitance C1. For the first capacitance C1 is equal to Q by V1. The charge is same for the both plates. So what is the value of V1? V1 is equal to Q by C1. What will be the value of the V2 then? V2 will be Q by C2. We are using the base formula C is equal to Q by V. So already we got voltage. We know the distance. We know the distance of each plate. One is 3 millimeter. Another one is the 4 millimeter. So we know the distance of the two dielectrics thickness. So what is E1? V1 by D1 and E2 is equal to V2 by D2. So this is the voltage gradient across each dielectric. The unit of the voltage gradient is the volt per meter square. So this is a tricky problem and there are a lot of formulas that using. Just I want to jot it down everything. First is if it is a parallel plate capacitor. So first formula is, I am writing here all the formulas one by one. So for the we have to calculate for the each and every parallel plate capacitor. Formula is epsilon A by D. Now we can calculate C1 and similarly we can calculate C2. And remember one thing, for this case A1 equals to A2. What is the next formula we have used? Next formula we have used here is the two capacitors R is in series. So C equivalent is equal to C1 C2 divided by C1 plus C2. This is the second important formula. What is the third important formula here? We know the equivalent capacitor. We know the voltage across them. So what will be the overall charge? Q is equal to C equivalent into V. Now, if we know the total charge, fourth point is we can calculate the voltage across each capacitor. How to calculate? V1 is equal to Q by C1. C1 we have calculated from here. V2 is equal to Q by C2 calculated from the first equation. What is the last point? We can calculate the voltage gradient. E1 is equal to V1 by D1 or E2 is equal to V2 by D2. So these are the main 5 equations we are using in this topic. So we are moving to the next problem. Predict the capacitance of a capacitor of a two parallel plate capacitor 30 cm by 30 cm separated by 5 mm in air. Calculate the energy stored by the capacitor if it is charged to a potential difference of 500 volt. So again, this is a problem of the parallel plate capacitor where the area of the each plate is given as the 30 into 30 centimeter square is equal to 900 centimeter square is equal to, we can write 900 into 10 to the power minus 4 meter square. We are only using the SI units, and for this problem we will write it in the SI units only. Next, the separation between the two is the D is given as the 5 millimeter. What is the meaning of 5 millimeter? 5 into 10 to the power 3 meter. And what is the formula of the capacitor for a parallel plate? Epsilon A by D. As there is no dielectric constant is mentioned, we will assume that the epsilon is equal to epsilon naught. So what will be the value of this? So the value is, we are putting the value that epsilon A, or we can write A by D by epsilon. Both are okay. We have used here A by D by epsilon. That also we can write. That is coming the same value. So A is equal to 900 into 10 to the power minus 4 divided by epsilon into D. What is the D? D is 5 mm, 0.005. So we are getting the value of the capacitor as 16 into 10 to the power minus 11 farad, or we can tell 1.6 or we can change it into the picofarad unit also. Now, if it is charged in the 500 voltage, what will be the energy? So, energy stored in the capacitor formula is half CV square. So, here C is known, V is given in the problem, and V is given as the 500 volt. So, if we put the value half 0.5 C we got from here into 500 square. So, we got the value 200 into 10 to the power minus 7 joule. So, this is the form of the second problem. So, what is the formula we are using here? First thing, we are using here the value of the total capacitance. epsilon A by D. And what is the another formula we are using here? E is equal to half CV square. So this is the question number 2. Now we are moving to the question number 3. The capacitance of a capacitor formed by two parallel plate capacitors of each 100 centimeter square in area separated by a dielectric. So only we are using one dielectric of 2 millimeter is. So what is the value of the capacitor? 2 into 10 to the power minus 4 farad. So the potential difference of 20 kilovolt, is applied. Determine the total electric flux in coulombs and potential gradient in kilovolt per meter. Calculate the relative permittivity. So for the first problem, C is equal to epsilon A by D, because we will start from the third part. Determine the relative permittivity. We are starting from this one. Determine the relative permittivity. We are starting from this. So the first thing is C is equal to epsilon A by D. Now epsilon value is not given in the problem. C value is given. So 2 into 10 to the power minus 4 is equal to epsilon. What is the value of A? A is 100 centimeter square. And we have to again convert it into the meter square. So 100 into 10 to the power minus 4 by D. What is D? D is 2 millimeter thickness. 2 millimeter thickness means 2 into 10 to the power minus 3. Now, we have to calculate the epsilon. So, what is the value of epsilon then? What is the value of epsilon? Epsilon is equal to 4 into 10 to the power minus 7 divided by 100 into 10 to the power minus 4. And what is epsilon? Epsilon is, so this is the permittivity. What is epsilon? Epsilon means epsilon 0, epsilon r. So if we calculate the epsilon 0 value, that is epsilon 0 is equal to 8.854 into 10 to the power minus 12. And if we put the value here, we can calculate the value of epsilon r. So this is the first topic of this. 4 into 10 to the power minus 7 divided by 10 to the power minus 2. So it is coming 4 into 10 to the power minus 5. So from here we can get the value of the epsilon r. Next is determine, first part is okay. What is the next part of this problem? For this problem, the next part is calculate determine the total electric flux in the coulomb. So already we have the value of capacitor. We know that the voltage 20 kilovolt is applied here. We can easily calculate using the formula Q is equal to C by C into V. Capacitance value is given. Capacitance value is given as the 2 into 10 to the power minus 4. And what is the value of this? 20 kilovolt. So it will be we can calculate the total amount of charge from this formula. So, and what will be the unit? Unit will be coulomb. Then we have to calculate the third part, the potential gradient. Potential gradient is voltage across the capacitance. Here only one dielectric is there. So voltage is 20 kilovolt. And what is the distance? Distance is the 2 millimeter. So what is the voltage gradient? Voltage gradient is 10 to the power 6 volt per meter. So this is the question number 3. First we are using the parallel plate capacitor formula. Parallel plate capacitor 2 CE is equal to epsilon A by D. Capacitance value is given, A value is given, D value is given. So we can get the value of epsilon, and epsilon is equal to epsilon 0 into epsilon R. So if we put the value here, we can get the value of the epsilon R. Next part is again the same, that the capacitance value is given and Q is equal to C into V. V value is given. So we can calculate the total charge, determine the total electric flux. According to the Gauss law, the total flux enclosed is equal to charge. So this is we are using the Gauss law here. We are using the Gauss law here. And third formula is equal to voltage across the capacitor by the distance between them. So voltage across the capacitor is V. So V by D is equal to A. So this is also a problem of the parallel plate capacitor. We are giving 20 kilovolt. Capacitance value is 2 into 10 to the power minus farad, and the distance between them is 2 mm. So these values are given in this problem. Next, a cylindrical capacitor having a length of 8 centimeter is made of 2 concentric rings with the inner radius of 3 centimeter and an outer radius of 6 centimeter. Find the capacitance of the capacitor. So you can see this is a cylindrical cable, and the cylindrical cable is used in the different purposes in the electrical engineering. So a cylindrical capacitor, a very good example of the cylindrical capacitor is the underground cable, where there is an conducting wire and on which there are the several coating of the insulating materials, and at the outside there is the polyphenol chloride, which is a very good insulator. So the shape of this is cylinder, of any cable is cylinder, and we have to calculate the total value of the capacitor because it also behaves like a parallel plate capacitor. One is the inner conductor, another one is the outer surface, and in between there are many layers of insulators or dielectric. But in this problem there is no dielectric is mentioned, so we can assume that the dielectric is nothing but the air, and air dielectric value is epsilon R is equal to 8.854 into 10 to the power minus 12. This is the epsilon naught, the permittivity of the air. So for this problem we have to first check the value. The length of this wire is given at the 8 centimeter. So we will first convert it into the meter unit. This is the first step. I am repeating ever and ever that all the units should be in the SI unit. What is the second one? The inner radius A is equal to 3 centimeter and outer radius B is equal to 6 centimeter. What is the meaning of the inner radius? The radius of the inner conductor. The conductor in the inside is known as the inner conductor, and it is given as the 3 centimeter. Similarly, the outer conductor value is given as the 6 centimeter. So what is our next step? Our next step is that it should be converted into the meter unit. It should be converted into the meter unit. 3 centimeter means, now according to the problem, A value is 3 centimeter and B value is 6 centimeter. So we got all the value. So what is the capacitance of a cylinder? For a cylindrical thing, the capacitance C is equal to 2 pi epsilon L B by A. So what is the value? 2 into 3.14. Epsilon value is 8.854 into 10 to the power minus 12 divided by ln. ln is nothing but the log base E. But many students do this, cannot understand it or take the normal log. No, ln is always log base E ln B by A. What is the value of B? 6 into 10 to the power minus 2 divided by 3 into 10 to the power minus 2. So 10 to the power minus 2, 10 to the power minus 2 cancel out. So it will be 2 into 3.14 into 8.854 into 10 to the power minus 12 by ln into 2. And from here we can get the value of the capacitor. And what is the unit of the capacitor? The unit of the capacitor is always in the farad. Here in this problem we have to remember one thing. While we are calculating the capacitance, we will take the outer surface radius first divided by the inner surface radius. So this is the question number 4. Now we are moving to the question number 5. The plates of a spherical capacitor. So it is a spherical capacitor. So spherical capacitor means you can see this is a sphere. So for the spherical capacitor, there are two radius. Radius are 38 millimeter and 40 millimeter. So this is 38 millimeter. The inner radius is 38 millimeter and the outer radius is the 40 millimeter. So what is our first step? First step is we will convert it into the centimeter unit. So we got this value. Calculate the capacitance. So for a parallel plate capacitors, we have this formula 4 pi epsilon AB divided by A minus B or B minus A. Which one is the greater? So 4 pi 3.14 into epsilon. Nothing is mentioned means we will take it as the air. Now A into B, A value is given in the problem and this is the A value and B value is given. So A is the inner radius 38 and this is the outer radius. B minus A is equal to 2 millimeter. So if we put the value, we can easily get the value of the capacitor. Now, what will happen if the both capacitors are in the parallel plate form? So what will be, if the capacitance value is same, what will be the cross-sectional area of the parallel plate. So already we know C is equal to epsilon A by D. Here epsilon is nothing but the epsilon naught, because the value is itself in the normal medium in the air. So what is A is equal to C into D divided by epsilon. C into D divided by epsilon 0. Now what is D? Here in the problem given that the distance is same plate separation of the capacitance. So this is same like the B minus A, 40 minus 32 millimeter. So what is the value of D? D is equal to 2 into 10 to the power minus 3 millimeter. Now if we put the value in this problem, we can get the value of the capacitor. So this is the next problem of the capacitor. So what is the step? First we calculate the capacitor. Capacitor is equal to C is equal to 4 pi epsilon AB B minus A. Now what is the next case? Next case we will put the value of the A and B. A is the radius of the inner surface and B is the radius of the outer surface. So if we put the value here, we will get the value of C. In the next part, what must be parallel plate area? So we have to calculate the area of a parallel plate capacitor with the same plate separations and capacitance. So capacitance value is same from this problem, whatever we have calculated, epsilon A D by epsilon 0. So if we put the value, what is D? D is the distance, the width between the B minus A. D is equal to B minus A. 40 minus 38 is equal to 2 millimeter. So if we put the value, we can calculate the value of the capacitance. Next problem. Find the capacitance of a conductor sphere of 2 cm diameter covered with a layer of polyethylene with 3 mm thick and permittivity is 2.86. So here also same type of problem. We have a sphere of the diameter. Diameter means the inner diameter is given. And what is the diameter? Diameter is 2 centimeter. See, this is the diameter. So diameter is equal to 2 centimeters. So what is radius? Radius is 1 centimeter is equal to 10 to the power minus 2 meter. Now it is given that the polyethylene is the thickness of the 3 mm. So what is the meaning of the 3 mm thickness? 3 mm means 3 into 10 to the power minus 3 meter is the thickness. So if the diameter is 2 centimeter, radius is 1 centimeter is equal to 10 to the power minus 2 meter, and the thickness is equal to basically A, the radius of the inner, by B, the radius of the outer surface. So we can write B minus A is equal to, the thickness is given 3 mm. 3 into 10 to the power minus 3 meter. Then what will be the capacitor? What is the value of the B? B will be A plus the distance. So A is 2 centimeter plus 3 millimeter. So it will be 2.3 centimeter is equal to 2.3 into 10 to the power minus 2 meter. So we got the value of A, we got the value of B. Now we have to only put it in the formula. C is equal to 4 pi epsilon A B B minus A. So if we put the 4 pi value, we know epsilon value is nothing mentioned, means AR, means 8.854 into 10 to the power minus 12. A, B value we have to calculate only. And after solving this, we can get the value of A and B. So we are moving to our next problem. This is a special problem of this chapter, which consists of some different types of formula. And in your tutorial question bank, there are two problems using the same formula, and we are discussing only one problem here. Another problem is same, only there is some variations in the digit. So first is the first problem. What is a conductor wire of a diameter 1 millimeter and conductivity is 1 into 10 to the power 7 ohm per meter? What is the meaning of the conductivity? Conductivity is generally written by sigma is equal to 1 by resistivity is equal to 1 into 10 to the power 7 ohm per meter. What is the meaning of the conductivity? The property of any conductor to allow the flow of electrons. The property of any conductor to allow the flow of conductors has 10 to the power 56 free electrons per meter cube. So in per meter cube, where and the electric field of 10 millivolt per meter is applied. Determine the charge density of the free electrons, the current density and the current in the wire. So, in this case, we will know that the volume charge density is equal to given as the N number of electrons into the charge of electrons. Here and per it is not written here actually. Rho V is equal to charge per unit volume. So how much charge is there? Number of electrons is 10 to the power 56 electrons per meter cube, means per volume, and the charge, electrons charge, we know electrons charge is 1 minus 1.6 into 10 to the power minus 19. So N is equal to 10 to the power 56. And what is the charge of the coulomb? Minus 1.6 into 10 to the power minus 19 coulomb. So what is the total value? Minus 1.6 into 10 to the power minus 1.7. This is the coulomb per meter cube. So because it is given that the free electrons of this per meter cube. So we got the value that minus 1 and this is written by the rho V, the volume charge density, charge per unit volume. So what is the next problem? Next problem is calculate the current density. Current density. What is current density? Current density is written by J. Current density is written by J means current per unit cross-sectional area. Current per unit cross-sectional area is known as the current density. So we have to calculate here the current density. So how to calculate the current density? current density has another formula. J is equal to sigma into E. What is sigma? Sigma is the conductivity and E is the sigma into E. Where is sigma is the conductivity and what is E? E is the field applied. So sigma value is given in the problem 1 into 10 to the power 7 and E is the 10 millivolt, 10 into 10 to the power minus 3. So what will be the value? 10 into 10 to the power 4 ampere per meter square. What is the unit of capital J? Capital J is ampere per meter square. So what is the difference between these two? Current density is always written by capital J and small j is written for the J operator to tell the change of the phase angle. So whatever the small j is an imaginary number and can be denoted by the root of -1. So small j is totally different from the capital J. Capital J is the current density. What is the third point? Third point is the current in the wire. So how to calculate the current in the wire? We have already got the current density. I we have to calculate. Cross-sectional area is not given, but it is given in the problem that the diameter of 1 mm is given. So I is equal to J into A or J into S. What is the value of the S? S is the cross-sectional area is equal to pi d square by 4. Pi 1 millimeter. 1 millimeter means 10 to the power minus 3 meters whole square by 4. J value we have calculated. So if we put the value, we can get the value of the current. So this is the second part. What is J? J we got. (10 to the power 4 ampere per meter square we got. So what is I? I is equal to 10 to the power 4 pi 10 to the power minus 6 by 4. So we got the value pi into 10 to the power minus 2 by 4. This is the cross-sectional area. This is the amount of the current flowing in this. So this is the question answer. So here we are using three formulas. First one is the rho b is equal to Ne. What is rho b? Volume charge density. Number of electrons per unit volume. E is given, E is the charge of the electron. Charge of one electron. Second, we are using the value of the second is the current density. So current density formula is J is equal to sigma into E, or sigma is equal to conductivity. E is equal to field intensity. And if we got the J value, what is current? We know I or J is equal to I by S. I is equal to current and S is equal to the surface area. Surface area. So if we are using these three formula to calculate the total current. Now we are moving to our next session. So already we have discussed. So what is the calculate the equivalent capacitor? So there are two types of capacitor here. One is the series capacitor, another one is the parallel capacitor. For the series capacitor, the capacitor equivalent capacitor is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So 12 plus 20 plus 30. 1 by 12 plus 1 by 20 plus 1 by 30. So it is coming 60. 5 plus 2 plus 3. 10 by 60. 1 by C. So Cs is equal to 6 and the unit is microfarad. So this is for the series connection. For the series connection, the capacitance value is equal to 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. For the parallel plate capacitor, so for the parallel plate capacitor, all the equivalent capacitance is the numerical sum of the individual capacitor. So it is 12 plus 20 plus 30. So 62 microfarad. So this is the parallel plate capacitor. So today we have discussed the problems from the different types of the capacitor and the conductor and dielectrics. And thank you. We will meet next class.
Like, share and subscribe. Hit the bell icon for more updates.